So next up, we have Jason Ernst. Jason is a CTO of RightMesh, RightMesh project, which aims to connect the billion people using mobile mesh networks on smartphones. Jason holds a PhD in the field of mesh networking and heterogeneous wireless networks. Jason has more than 30 published papers on wireless networks, cognitive agents, FPGAs, and soft computing topics, and has presented his research at international conferences around the world. Please join me in welcoming Jason to stage.
Thank you for the introduction. Wrong way. No. Perfect. Okay, so the lawyers are requiring me to put this slide up. You don't need to worry about reading it. It's because we're in the middle of an ICO or a TGE right now. So just basically saying none of this is investment advice. So some of my background, like was mentioned, I have a bachelor, master, and a PhD in computer science. It's all focused on mesh networks or HetNet meshes. So meshes built out of a variety of different technologies. I've also been really involved in hackathons. I've got a bunch of funding over my career from NSERC and MyTax. In the sort of end of my PhD, I founded a robotics company. It was focused more on like a hardware, software platform. And mesh networks as well. So the idea was to create swarms of robots that could share their sensor information and control information with each other. That picture is basically showing an ODG robotics platform running with our stuff on it. The one thing that I really learned though in the robotics thing was that hardware is super expensive and pretty much every mistake we made cost thousands of dollars, so we quickly ran out of money. So the one thing I really learned is if we can do things in software, let's try to do it that way first. So I guess sort of the question that's sort of driving my talk right now is how is most of the data that's going to drive decentralized AI collected? It's all really assuming that there's fast, centralized, cheap, IP-based infrastructure networks. So it's things like balloons, satellite networks, fiber optic cables, cell phone towers, and these types of things. Or a sort of related question is how do most P2P networks work? The same sort of thing. So if you want to have a P2P network, it's not like P2P in that like my phone's going to talk directly to your phone. It's going to go through some centralized infrastructure and talk to your phone. So let's look at like the typical path for data communications. If we have two phones in the room and I want to send a message with most of our services that exist, so like Facebook Messenger, Slack, all the sort of things we have, it follows the path from the phone up through the Wi-Fi router or the cell phone tower to a bunch of regional ISPs, so like Rogers, Bell, all these types of people in Canada, AT&T in the States, these types of companies, up to like a few corporations that control the backbone of the internet, and then typically to some cloud service providers. When we talk about a P2P network, it mostly takes off the top bit of that. So we no longer have centralized servers involved anymore, but we still rely mostly on this centralized network that exists. So it's still all the same corporations are still there. But sort of what's the problem with this type of stuff? We have problems in the States like net neutrality coming to an end. There's endless sort of voting back and forth on whether it's going to sort of come to an end or not. So we basically don't have guarantee that data will be delivered fairly. It may be blocked, it may be slowed down depending on whether you're competing with certain parties in the networks now or whether your data is against the sort of beliefs of the people operating the networks. If you're always sending everything through centralized infrastructure, you're sort of more prone to having things tapped. So the NSA famously tapped the infrastructure between some of the servers that Facebook and some of the other big sort of corporations run. So like even though it was internally secure, because the infrastructure between the data centers got tapped, it was possible still to get at the data. So the sort of message here is like, I mean, we took out the top part with the database and the servers, but can we also try to remove some of the network infrastructure as well? The other sort of enabling technology in this space is that the phones themselves are increasingly getting things that will allow AI be baked into them. So we're seeing processors that have things like TensorFlow capabilities built into them. So because we can do more and more processing on the phones, can we make more localized decisions? And some of the earlier talks mentioned, making sort of more local learning and then communicating that up to a more global state. So from that point of view, can we do these types of things? So can we build geographically local AIs? And can we build infrastructureless networks to be able to enable this type of thing? So I won't talk a ton about RightMesh, so I'm not promoting our stuff too much, but basically there's our library, there's other sort of mesh libraries out there. The idea is you can package something into your phones or into your IoT devices that gives you this sort of ability to make the peer-to-peer connections, and also gives you the ability to have a consistent identity in these networks. So rather than depending on like an IP address or a MAC address or something that can easily be spoofed, we package in this ability to have a key pair that you can use to create a consistent identity and to sign the data that's coming in, so you can rely on the data. So the idea is you can have these networks that are built up of multiple different types of applications that are running, and you can have the data flowing through them, and you can make these local decisions in a network that may or may not be connected to the internet. So you might get these sort of islands of connectivity where some of the nodes are connected to the internet, sometimes they're not. And you still want to be able to have these solutions that work even though you're not always connected to the internet. So the previous slide showed just a bunch of phones, for example, but now this slide is showing an example where you have some small meshes that are forming, and within the meshes you also have sensors as well. So you could have some temperature sensors, you could have IoT devices. All the phones themselves could be sensors, so depending on what you're doing with the phone, you could have accelerometer data, and all of this stuff could be feeding into AI, and the whole time avoiding infrastructure. So what are some of the risks of AI? Providing the data, could ID people if it's not encrypted in the first place, or if it's able to be decrypted. So this could be things like gender, sexuality, religion, location, biometrics, all this sort of identifying information. By sending this through the infrastructure, it almost goes back to the panel when I was talking about the sort of Tinder example. Do you really want your Tinder information going to a centralized service where they could store it forever? And even though it's encrypted, maybe it's not quantum encrypted, so later on a better computer can crack the encryption. So you're basically trusting that they've done things right from the start. If you can try to keep some of that information away, or have it anonymized or aggregated or something like that, you can prevent things happening that affect your opportunities, endanger your life, or open you up to discrimination. So if you never centralize, you sort of reduce that risk a lot, but like I said, aggregate or anonymized. You also have to sort of inherently trust the people in the organizations and the governments that are running or have access to the infrastructure. The other sort of newer thing that's coming out is that the AI itself can be manipulated. So as soon as people find ways to make the algorithms do what they want, they can sort of have their way with it. So like, you're sort of seeing this with Facebook and the ads, and being able to, you're seeing like bias loops and stuff working their way in. So in the case of like a sensor network, you may be able to manipulate the way that the algorithms work by making fake sensors or making fake data coming into the network. So being able to prevent those types of things is super important. So a few sort of ways that you can secure and decentralize data for the AI. One is to just avoid infrastructure networks. One is to make use of delay tolerance and mobility as a feature in these networks. So you want to try to have AI that can function if the network is like separating itself or going offline periodically. If you want to be able to make these solutions work where you don't always depend on the internet being connected all the time. The other sort of key part is being able to give the data sources identity, so some type of key pair. That goes a long way to make sure that the data has integrity. Make sure the data is signed. So like a lot of this stuff is drawing from examples of things we've seen in the sort of early days when people are just rushing to connect everything to the internet as a data source and feed it into the AI. We sort of made lots of mistakes where there's just raw data coming in. security is always the afterthought. But now that we can sort of create these networks where the network itself has the keys attached to it as its sort of identity in the network, we can do this right from the start. When you're communicating between data sources and syncs, you can use end-to-end encryption on top of it. So not only just signing the data to make sure that it does come from the right person, but also making sure that it's, someone in the middle can't read the data as well. So only the intended sync gets the correct information. Anonymizing the data and aggregating where possible. So not all this stuff is like a security sort of concern. Some of it is also performance concerns. So like the more you can do like aggregation or like local learning in geographic areas, the sort of less traffic you need on these networks. So on these infrastructureless networks, probably the biggest problem is that one is that the internet links, when they do exist, if you want to share them into the network, are very sort of valuable and very limited, so they're almost like a limited resource. So you want to try to use that link as much as possible and do as much communication locally as possible. And then when you do the communication from the local mesh up to the internet, you want to try to aggregate things as much as possible. So to sort of sum things up, can we build these sort of locally geographic, local AIs? So the networks that can power it are starting to emerge. There's people like us, there's GoTenna, there's BlockMesh, there's quite a few different meshes that are forming around sort of blockchain approaches. But there's also technologies on the AI side that are starting to emerge that are also compatible with it. So things like SingularityNet, Cambria.io is a sort of robotics focused platform that's sort of similar. Blockstack just launched a decentralized app store. So a lot of these things working together, I think, is really going to power this type of approach in the future. Questions? Yep. Yeah, so right now we started with Ethereum. It uses Raiden for micropayments, but the way we designed it has been in a way where we could switch out the underlying stuff in terms of like the cryptocurrency, powering it underneath. So that's always been sort of one thing that we try to do right from the start. Also for an interoperability sort of perspective, working with other blockchain or other mesh solutions as well is another thing we're looking at. So interop with people like BlockMesh or GoTenna or things are also possible. Yeah, I mean, we recognize that like the biggest challenge to mesh is really like density. So getting as many phones deployed that are running compatible mesh as possible. So it's not just about like developers building on our stuff and us building apps, but also us working with anyone else that can also grow this ecosystem is the key.